Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to Cloud Test Lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
Okay. And just one more. Okay, yeah, fine. I think, yeah.
No, you could ask me. When a thread is already started, if they try to start it again, it throws an illegal thread state exception.
So, okay. Yeah, I got it.
Neha?
Yes, Shani?
How to determine what to use? I mean, when to use the runnable and when to use the class? Only if you are extending another class for a desired class, only then we have to use the runnable. Because once we use the extend keyword, then only implement is remaining. So is that the only
when we do both ways, if you observe the thread class, right, the thread class doesn't do anything. It implements the runnable interface. We have the thread class, right? If you go to this code, what does thread class do? It implements the runnable interface. I don't think I have. Yes. Anyway, even though I don't have like the Java code, even the dot class, you see, it is implementing the runnable interface, right?
Okay.
And it has some behavior on to make it function as a thread. There are some methods that are defined in the thread. But the bottom line, it is also implementing the runnable interface, right?
Yeah.
So, for example, let's say I have something, the account creation, I want to do it in a separate thread, right? If I extend the thread class, if I have a base class account, I cannot say my savings account can extend it and have thread behavior also. That cannot be done because I cannot extend two different classes in Java, right?
Oh, yeah.
So in that case, we go with the implementation of the runnable interface so that we have the ability to extend other class.
Okay. Okay. So the performance will be same because anyway the thread is implementing the runnable already, right?
Yes. But the performance gets hit whenever we are trying to create like multiple threads. See, actually what happens is, from the performance standpoint, if we create a new thread, right, it causes a performance overhead. That is the end slide we're going to discuss about anyway.
Okay.
I don't want to confuse people.
Yeah, that's fine.
By mixing it. So, are you people clear on the different states of a thread and two ways of creating a thread type? Extending the thread class and implementing the runnable interface. In either case, a thread is always an object of java.line.thread. Even we implement the runnable interface, we create a runnable object and we pass the runnable object to the thread constructor. Thread has overloaded constructor, folks. See, thread has an organ constructor and a constructor which takes the runnable object and which takes just the name. We can create a thread object by just giving a name. And there is one more constructor which takes the runnable object and the name of the thread. So I can just pass the runnable object and set it later, or when we pass the thread name, it sets the name for the thread. So even though when we have the runnable object, we have to create a thread class thread object by passing the runnable object. So we use the same start method in either case to start the thread. So any doubts on this?
Hello, Neha.
Yes.
I have one question. So how we can decide that we have to use synchronized keyword and volatile keyword?
See, volatile is used for variables. Okay. These are two different questions, folks.
Yeah.
Let's talk about volatile. Volatile,
Okay.
we make it for a variable. So basically, when there are multiple threads, right, we have discussed that there is a cache of memory that the threads maintain, right? So, but if you say a variable as volatile, it doesn't try to look up from the cache. It tries to get the exact value from the memory. It doesn't try to look up in the cache, because volatile, we make it for a variable wherein the data for the variable or the value for the variable changes very, very often. The perfect example is temperature, right?
Okay.
Temperature changes every now and then, right? So we don't want to retrieve that from the cache. It always gets the latest value, the last modified value, the latest value. All the threads reach the modified value for the volatile variable. Okay?
Okay.
That is one question. What is the second question?
Synchronized keyword. How we can use synchronized keyword?
Whenever, if multiple threads access some code, right? When there is, in the scenario of a joint account that we discussed, right? When multiple threads access it, the behavior doesn't work as expected, right?
Yes.
It's completely the business what determines to make the code asynchronous. We see, if there is any possible effects, or errors. I'm not saying the program errors, right? There are some kind of calculation errors. What happens because of multiple threads accessing the code? Then we make the code asynchronous.
Okay. So it must take one thread at a time.
Yes. When we don't want, when multiple threads access it, if there is some, if the functionality doesn't work as expected. For example, I'm reading data from a database, let's say, right?
Okay.
So there can be multiple threads that is accessing that specific code, right? Anyone can read it. There is no harm, right? But let's say we have like the same record which is update, let's say, right? So when one thread updates it, right? You don't want other threads to go ahead and update it, so that they update the stale data, right?
Yes.
I'm just giving for an example. Might not be a perfect business scenario though. But when each time when a thread updates it, it sees a version it got. Let's say, for example, in database we have the version. Both threads got version, and both threads are trying to update it. When one thread is updated, it is version 2, right? When they are able to, if they were allowed to, update simultaneously, it's like you have two version 2s that are created in parallel, which is not the case, right?
Yes.
So we don't want them to update like simultaneously. We want like when one thread tries to update and create a new version, we just want to stop the other thread by doing this, right?
Yeah. So they can read simultaneously, but they cannot update simultaneously.
I'm just giving you an example.
Yeah.
For you to understand. There are some scenarios which can be accessed by multiple threads without any issue. There can be some part of code what you are trying to achieve with the code. They can be accessed by multiple threads without causing any issue, right?
Yes.
But there is some code which leads to, functionality issue when multiple threads are accessed. In that scenario, we synchronize the code.
Okay. Okay. Thank you.
So, any other doubts in creating a thread, about the run method, about different stages of the thread? So we have different methods that are present in the thread class. So we have already seen the start method. Start method is used to start the thread in the separate path of execution. And this start method invokes the run method on the thread object. Folks, we have already seen it. We said t.start. But we haven't called the run method. But the code inside the run method is getting executed. Right? So if you see this example here, this particular example, we are not calling the run method here. We're not calling, even in this example, we're not calling the run method, right? If you see this code, we are just calling the start method. What does the start method do? It starts the thread in a separate path of execution, and it internally calls the run method. As the start method is internally calling the run method is getting executed because we are not calling the run method. So how is it getting executed? The start method internally calls the run method. So what is the run method? The run method is the exact task that the thread is performing. So whenever we have a thread object using a runnable target, the run method is invoked on the runnable object. And we have seen the setName method, which is used to set the name for the thread. And folks, we have the priority, priority that can be assigned for the thread on a scale from 1 to 10. 1 is of course being the lowest priority and 10 being the highest priority. We can use the set priority method to set the priority and get priority to get the priority of the specific thread. We have something called as a daemon thread. What is a daemon thread? A daemon thread is something which runs in the background. It is a very less prioritized thread and it runs in the background. So if you want to make a specific thread as a background thread or a daemon thread, we call the set daemon on the thread and we set it to true. And folks, we have the join method on the thread. So when we call a join method on a thread, what happens? It causes the current thread to stop until the second thread completes or terminates. When the thread invokes this method on a second thread, for example, I am executing in the main thread. For example, I say t.join. So the main thread stops until the t gets completed. So folks, here, let's say in this example, right, if I'm asking it saying t2.join here. For example, let's say I have started both these threads, right? So I'm saying t2.join. So folks, what is the error that I'll get here when I say t2.join? The join thread gets and throws an checked exception. It is interpret exception. So we have to handle it. So folks, let's see, I'm saying I created two threads and I'm saying t2.join. Right? So what happens when I say t2.join? The current thread. What is the thread that is executing this code? It is the main thread, right? The main thread stops and it waits until T2 is terminated. So let's see folks, when I run this, right, this doesn't get executed until T2 gets completed. The thread 2, what is this T2? We named it as the thread 2. The thread 2 should get completed and this comes as the last. I mean, it's not at the last, it comes after the execution of the thread 2. Right? Let's say if I don't have this, if I don't have this code, folks, follow this, this is very important. When I run this, you see, this is not coming last. It has executed the main thread, which is executing this. It has executed a way back before T2, which doesn't happen when I say T2.join. Let's see the output. See here, this got executed even before thread 2 is terminated. Thread 2 is still executing, but this piece of code which is executed by the main thread is done a while before T2. That doesn't happen when I say T2.join, because when I say T2.join, what am I saying? I'm literally saying it join at the end of T2. When I'm saying T2.join, it literally means I'm asking it to join at the end of T2. So when I uncomment this code, basically when I say T2.join, right, this particular piece of code which is executed by the main thread, it waits when the program encounters this line. When it executes T2.join, it stops the main thread until T2 gets executed. See, this comes last, not the last, it comes at the end of T2. So folks, clear on this join method?
So Neha,
Yes.
the join method is always used to prevent the execution of main thread before the subthread?
No. In real-time scenarios, there will be some scenarios wherein, the second process is dependent on the first process. Let me tell you this way. In a financial domain, when we want to analyze the stock price for a week, right? There is one thread which gets the stock value for the week. And there is another thread which analyzes it and tells you, if it is increasing across the week or if it is decreasing across the week, and many more tools. So the thread which performs the analysis should wait until let me tell you this way. There are two threads. One which fetches the price details of the stock for the week, and another thread which performs the analysis, right? You cannot perform the analysis until you fetch the price, right?
Yeah.
So we can start both the threads, but I say T2.join. I start the first thread and I say T2.join. I want to make this thread wait until the other thread fetches the price details for the week, right? So in real-time scenarios, there will be like one process is dependent on the other. In such scenarios, we use the join method.
Okay, but here, how does T2.join affect the execution of T?
I'm sorry? How T2.join
affect the execution of thread T?
No, it doesn't have anything to do with thread T.
Oh.
T2.join has nothing to do with thread T.
Yeah, but if I want T2.join to wait for the execution of T, I can just call wait and give a random number. That's the only way.
No, until sleep. Wait is something when, let's say when we are waiting on an object, right? When we are waiting for a lock, that's what happens. Okay, let me run this now. Now you understand it. The T2.join has nothing to do with thread 1 or the thread T. Let me get T1. We just don't get confused with T or T1. See, the T2.join has nothing to do with thread 1. T2 and T1 and T2 are two independent things. They don't have anything to do with each other.
So if I give T1.join, the same
yes, when they say T1, see, you might get the same output, but it's not.
Hello?
Here we are saying, hello, are you able to hear me?
Yeah, now I'm able to hear.
Okay. When I say T1.join, the main thread, after this line, it joins at the end of T1. It's not bothered with T2. See, you see it here? It has come in between, right? Now, it waits for thread 1 to complete, not thread 2, right? So it has come even before thread 2 because thread 2 has no relationship now with the main method, right? They are not controlled by each other, thread 2 and main now. Now the main method is controlled by thread 1. When the main thread executes this line, it waits until T1 gets completed, right? But before that, it is waiting for T2 to get completed. When I said T2.join, the main thread is waiting for T2 to get completed. But when I say T1.join, it waits for T1 to get completed. You understand the difference? When I say T1.join, we are like, the system is literally saying to the main method, join at the end of T2. Just, just pause for now or stop for now and resume at the end of T1 or, join at the end of T1. That's what is literally the English meaning if you ask me. It is saying join at the end of T1. When I say T1.join, it is join at the end of T1. Is it clear?
Yeah.
Okay, this is about the join method. And folks, we have the interrupt method. When we call interrupt method, it interrupts the thread and it causes it to continue the execution if it was blocked for any other reason. And we don't usually call the interrupt method in code. We don't really do that. And we have a method is alive to check if a thread is alive or not. If it returns true, the thread is alive, and if it returns false, the thread is in the dead state. Like the code inside the run method is completed, or the thread has finished its task. Right? When we start the thread, it starts returning true until the run method gets completed. It returns true from the starting of the thread till the run method is completed. The isAlive method returns true. So folks, any doubts on these methods? Did you see your set name, run, priority, daemon, join, and all these things? So folks, any doubts before we move on to the second set of methods? Or not only this method, any threads any doubts in threads, whatever we have discussed so far?
Yeah, what actually is a daemon method like?
There are some background threads. Okay, let's say you want to, the JVM has some threads that it runs in the backend, to calculate the memory and, to perform the garbage selection and all that, right? They are the background threads, which are set with very low priority. Their priority is less. So, for example, if we launch some threads, right, they take more priority than the daemon thread. The daemon thread is a background thread and it is run with very low priority. That is what is meant by a daemon thread.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.